Good morning. Welcome to the webinar about AutoCrear, automatic clearance and creepage analysis. My name is Urs Simler. I set up an agenda for today's webinar and it looks as follows. First, I'd like to introduce the presenters and the company we are working for, and then we will talk about the solution AutoCrear from the company Elaborate, and we'll see how the interface is looking like, how the workflow and session management will working. We are going to have a look at that in PowerPoint at the first site, and then we'll see also the product in a live demonstration. So the most of the time we'll see AutoCrear as a live demonstration in the nice user interface. And due to the short time, we'll just see, let's say, the complex assembly, and we'd like to analyze this assembly with AutoCrear. At the end of the day, at the end of the presentation or the webinar, or during the webinar, if you have any questions, feel free to type in your question in, let's say, the question panel you'll find in the webinar application, in the GoToWebinar application. So, who is speaking? My name is Urs Simler. I'm a CAD simulation expert. I'm working for a company called GIA Informatik AG. And GIA Informatik AG is a reseller of PTC and is also a reseller of Elaborate. I will talk about them later. I'm a technical guy and I'm doing some, let's say, webinars, consulting, trainings on simulation products in the CAD environment. In the call there is also our sales guy, Daniel Losley. He's responsible for the financial items, and if you have any question about quotes, trainings and so on, feel free to contact him. Daniel and I, we are working for a company called GIA Informatik AG. GIA Informatik AG is a Swiss company. We are located in the middle of Switzerland, around here. And maybe you know a little bit Switzerland. Here is Basel, here we have Zurich, and around here we have Bern. We are about 160 people right now in the company. We belong to a bigger company called Müller-Martini, and we are the, let's say, the daughter of this company. We have, let's say, three services we can offer. One service is in, let's say, the SAP environment. We have our own IT services, and let's say the third one is about CAD and PLM solutions. I'm working in the CAD and PLM solution. GIA Informatik is also certified, ISO certified. You can see that here. And we are working with quite a lot of partners. In the CAD business, we are working with those partners here. Let's say the main partner is PTC, and beside that main partner, we have some other ones I will talk a little bit about right now. We're doing, let's say, some, as I said, some in the CAD environment, PLM environment, we're doing some training, consulting, and as today, we are doing also some sales presentations. In the environment of PTC with the product Creo Parametric, Creo Elements Direct, Windchill and MatCAD, and ThingWorks and Navigate and other products from PTC. Beside that, we are working with partners. This is a partner from the topology optimization environment called CAESS. Today we will talk about the product AutoCrear from Elaborate in Nuremberg, Germany. We're also working close with CFD simulation from Mentor Graphics, Flow EFD. We are going to support solutions from an Austrian company called TechSoft and from another German company in Munich called Software Factory. We are also monitoring PDM systems from customers in Switzerland. We have an own PDM ERP interface. We're doing trainings in our own training center at Oftringen, but we can also offer trainings on site. This is also no problem, and we are quite experienced. We have about 130 man-year experience in the CAD PLM environment. Okay, let's talk about, let's say, electrical clearance and creepage analysis from Elaborate. The product is called AutoCrear version 2.0. Why do we have such a product? I mean, when we have electrical components, there are very, very strong safety regulations about, let's say, clearance and creepage environments, because when you have here a potential, and here is the same thing, we have to make sure from a safety aspect that these distances between those two potentials, that these distances are reaching a certain level. And these levels here are defined in safety regulations. The safety regulations are different from each country to another country, and we just have to make sure that the distances over the air, we call it clearance, and the distances along the insulators, that they are reaching a certain level depending on, let's say, depending on the net, depending on the potentials. And this is a very, very complex thing to do that in a 3D environment. I mean, it's quite easy when you have to measure that one in a 2D environment. But right now the products are designed in a very, very compact way, and therefore you really have to make sure that these distances are reaching a certain level. And the company Elaborate, they built a such solution where you can do that efficient on, let's say, 3D CAD data. After 5 years of research, they're building a new solution. They were founding an own company, and yes, I like to talk about this very, very efficient software, AutoCrear v2.0. Okay, the user interface, we'll see that later on live, is very unique, and it's very easy to learn. So I've never seen such a CAD, let's say, solution which is that nicely structured as AutoCrear. I will see the 3D window, we'll see all the tools, let's say the model tree, and on the right side we will see how the workflow has to be defined, and we'll also have then, let's say, a nice documentation tool up here. Okay, what's the workflow we have to follow? Of course, at the beginning here we have to bring in a 3D CAD data, and then when we brought in that CAD data, we have to define, are the components, are there insulators, or are there metal components, and of course that's quite easy to do. And then we have to, let's say, bring those components together to electrical nets, we have to define what are the regulations, what are, let's say, the distances here, and in the end we are doing some post-processing. And the worst thing, in the end, we should also, let's say, create a report of the work we did. And of course, if we have some changes in our CAD data, we'd like to reuse all, let's say, the definitions, and we like to reanalyze our components. Bringing in, let's say, the CAD data to AutoCrear, there are different ways to do that. By default, everybody gets, let's say, the step importer. This is for free, and if you like to, let's say, open the CAD data from those systems directly, there are also some interfaces, additional interfaces are available. For Creoparametric, I'll show that later on, there is a, let's say, direct gateway. So in Creoparametric you can push a button and then all the data will be transferred to AutoCrear. Okay, and then the data is right now in AutoCrear. It will be visualized and you get the opportunity to show them with special colors. These colors they show you, is the component conductive or is it insulator? And of course this metadata can be easily assigned in the component for each part, even for some special surfaces, and you'll get, let's say, some direct feedback by changing the colors or by directly unhiding the components when a CTI value is assigned. So it's quite easy to do that step assigning metadata to our components. There are also some special, let's say, simplifications available. When you have some springs or some screws with thread on it, then you can simplify these components in order to get perfect results. And there is also capability available about cementation. If you have a part touching another part, then you can say there is a cementation. So let's say the creepage and clearance passes on a cemented component will be different to the passes on uncemented components. Okay, when you define this metadata, then you have to build, let's say, the electrical nets that can be done automatically by joining those nets which are touching. And in the end, you also can then go in and say, okay, these nets, they have a specific potential here. You can define the voltage levels. Here you can define, if you like to deal with alternative current or direct current. You can define the grounded nets and so on, and you can also, let's say, bring potential free nets like screws or springs, that kind of stuff. And in the end here you have a special component or special net. It's called touchable potential free. Here you can switch between, let's say, grounded or potential. So it's a special thing. I will show that later on the help environment. There is also capability to, let's say, bring in your own geometry. Right now you can bring in some additional electrical nets by adding some points and surfaces in your assembly to, let's say, analyze the distances to these items in the future. At the end of this year, there is also, let's say, a norm finger you can bring into your components to see what are the distances from a norm finger to your potentials. Then when you defined all that nets, then you are defining some parameters. You're bringing in, let's say, the regulations, the safety regulations. What are the distances required for a specific voltage difference that can be easily done in AutoCrear with a standard table. In the background under the hood there is an Excel file for that one. If you like to, let's say, change the Excel file, you can do it over that one. Or there is capabilities inside to use custom parameters, let's say, just to play around in AutoCrear to see maybe distances between specific items in order to, let's say, test special paths. Okay. And at the end, when you define that step, then you are running the analysis. When you run the analysis, there is also shortcut behavior is implemented in that solution. So it means when you have here one potential on the other potential, and between there is a conductive part, the distance here will be shortened by this conductive screw or what else. There is also, as I explained before, cemented and uncemented behavior available to, let's say, lengthen a part here, as we can see on those two pictures. And there is also the behavior of the groove width is nicely implemented. So in an example, if this groove width here, or if this cut is, let's say, 1 millimeter and the groove width is 1.2 millimeter, the path will go directly through. If the groove width is below 1 millimeter, the path will go that way. And if the groove width is quite small, the path will be lengthened here in that way. So with this behavior, you're really able to, let's say, analyze realistic paths of your creepage and clearance behavior. Okay, when you analyze your components, then you have to do some post-processing result investigations, and these result investigations can be easily done with the help of, let's say, this matrix over here. You see all the combination, and you see, let's say, the violation paths here, and the violation paths can be documented. You can bring in some additional information by adding some comments, by adding here, or by deleting them, by filtering them, and all, let's say, the comments you're bringing in, all those comments will be stored for later documentation. Okay, when you are doing, let's say, this post-processing, then you have a very nice capability called Show Me a Path window. This path window is cutting here your assembly in order to see, let's say, these paths very, very clear. So this is a very, very useful features, and additional features are available in order to highlight the paths, in order to bring in some additional positions or views for the documentation later on. So let's say the thing here combined with the path window helps you to see the paths in complex assemblies very easily. So next point, documentation. I mean, this is yes, this is quite a pain when you analyze the components. When you did some simulation, you have to do a report, and I've never seen such a solution which is doing in a very, very short time a nice report as AutoCrear is doing. So we'll see later on the report can be customized, and can be saved as a PDF or HTML. At the end of the year, there should also be available a Word documentation. And this is very helpful because the document, I will show that live, will be done within minutes. When you have to do such a documentation by hand, that it will take you hours to days. Yes, that's more or less. No, that's not all. I mean, you can save all this information about the passes. You can save the results as a ACS file, and this ACS file can be used by other people in your company which do not have AutoCrear, the full version. So for those people, we are having a nice solution, a viewer, and in this viewer, the user gets, let's say, the capabilities to view the results and to see all that passes in order to take part at the process of clearance and creepage analysis. This is, let's say, the free viewer. Beside that free viewer, we have an extended viewer. This is, let's say, not free, this extended viewer. It gets you the opportunity, the capability to take part at, let's say, the process of the documentation of this clearance and creepage paths. You're getting capabilities to bring in your own comments and yes, take part at the analysis process. That brings me to the last, nearly the last slide here. That are the products of AutoCrear, of Elaborate. We have AutoCrear itself, the full version. There we have all the capabilities available. I'll show that during demonstration. And beside that, we have the free AutoCrear viewer. I also show that one. And we have, let's say, some viewers for CAD users of CATIA, Anix, SolidWorks, and so on, which also have, let's say, the capability inside to bring in comments and so on. And the same thing is also available for Creo parametric user. We call it CCX viewer. This is also a product. Okay, let's see AutoCrear live. As a demonstration, I told you we like to work with an advanced model here. We like to analyze this connector. Therefore, I'm going for my AutoCrear version 2.0, and this is the user interface. Here we can say, okay, I want to import an assembly. In that case, I'm working with a step file, and I'm going here for my documentation. Here should be my step file. This one here, I'm going to bring that step file in. As you can see right now, I'm spinning around here my assembly right now. Oh, the import takes a while. I'm spinning around the assembly with a 3D mouse. This is also supported. Up here we have in our toolbox, we have the capability to select items. Here we can change between wireframe and other shading and so on. Here special capabilities to spin around. Here maybe when I want to see that component from front, I'm typing F8. Or here I have capabilities to bring in some cross sections. Taking it out again, and here capabilities to show, let's say, the material colors or the original colors. Material colors means red is undefined, so I did not assign some metadata right now. Therefore, let's say all the components here, because the CTI value, comparative tracking index value, is not defined yet. Okay, here we have the model tree. We can hide that, or we can, let's say, undock or dock it. and down here there is additional menus. Okay, let's start with our workflow. Up here first we have to define which components are conductive, which components are insulators. Therefore, just clicking on that component and I can say, okay, this component, right mouse button, is assigned with that CTI value, comparative tracking index value. Okay, so the color is changing to blue, and here we see, okay, 200 is assigned. We also can, let's say, hide all those components which are assigned with a CTI value. So in the main window, I can clearly see which component are not assigned with metadata. So now I will assign some other components as with insulator properties. I'm selecting them, pushing that button, they will disappear. I'm taking those components here and I'm assigning a CTI value of 200. Of course, you can change the CTI values, and depending on higher CTI values, the rules for the creepage passes will tell us that these good insulators will lengthen, let's say, the passes itself, or let's say we'll change the rules for the passes. Okay. Right now all the components here should be conductive, therefore I'm drawing a box and I'm setting them, all of them conductive. All the components disappear. I'm unhiding all the components and I can clearly see with gray and blue colors which components are conductive and which components are insulators. Quite often you have the situation here, I'm going to let's say show only those tools part, that you are buying a part, you're getting a step file, and let's say here, you know, on that component, that maybe this regions here, they are conductive and all the other stuff is insulator. Therefore, we easily can change here to select, let's say, the surfaces. I'm just pressing number 3. Now selection of surfaces is available. I'm selecting them with Control button pressed and I'm expanding, let's say, those surfaces in order to get more of them, and I'm assigning here conductive properties. Okay, I'm setting them conductive in, let's say, that area. We see, okay, the color is changing to blue, and we are getting here some additional information that those surfaces here are assigned with conductive properties. And of course also the color is changing. Now I'm going to unhide or to show all the components, and I can see here the information about conductive parts. Now I'd like to go for my components here. I'm going to separate them. Okay, and like to show you what let's say a simplification means here. If I have, let's say, a potential here and the springs are conductive, let's say the shortest path will be, let's say, maybe that one here, this distance. If let's say in green, if I turn my spring maybe by 90 degrees, the shortest path will be maybe changed to the yellow line. So with, let's say, some simplifications or special parts, I can say for springs and maybe screws with thread on it, I want to work here, I want to simplify that one here, that springs, and out of that springs I want to make a tube or a cylindrical surface on, let's say, that guy here. So I'm taking, let's say, the worst case scenario on the screw, on the springs, in order to get, let's say, the shortest distances between that component. So that means I can go in and say, okay, those springs here, I'm selecting then right mouse button, they should be simplified with a special item. They should be springs here. Okay, and this guy down there, where is it here? This one, the thread is modeled here. I wanna set here the type to screw. One moment, set the type here to, I did spring, yes. Here we can see also special symbols. Here we have the spring. Here we have the screw symbol. I'm going to apply now my metadata. And by applying this metadata, I will be, let's say, sent here to the next step where I'm going to define the net here. All nets or all conductive components will be automatically merged when they are touching here. Okay, and I can see here, I'm hiding the insulators. I can see here those net. Okay, it will be highlighted by green colors. Okay, when I'm looking maybe from that side here, I can see, okay, there's net number 8 and net number 4. They seem to touch, but there are different nets. What's the reason? When I'm zooming in here, I can see, okay, oops, there is a gap between those net. And the gap is, let's say, has a certain value. And in order to bring those two net together, I'm setting the merge distance to 0.1 millimeters, and I'm auto-merging that net. And you will see, okay, net 4 or 8 will disappear. Okay, net 8 was disappearing. Here I'm also getting the capability to, let's say, bring some net together. Here I have a, let's say, a surface net, and here I have, let's say, a physical component net, and inside that blue part there is a connection between. Therefore, right mouse button, I have to merge those net. And we'll see also the number of net here will be decreased. I'm doing the same down there between that guy and that guy. I wanna do a merge. Okay, and at the end here I have this number of net here, and by double clicking it I want to bring in some meaningful names. MC, MB, MA. Okay, this is maybe ground. Okay, this is S1 for spring 1, spring 2, spring 3. This guy here is maybe R1, and this guy is P1. Okay, right now it's defined as potential free, and here I can move those guys here and say, okay, there is potential on it. This here should be grounded, and these two here also with potential. Depending on potential or not, let's say these nets can be sources or can only be targets of my later analysis. In that area here, up here, I can say, okay, I already did a simulation with a similar assembly. I can import the configurations, reuse them, or here I can say, okay, I want to work with direct current or alternate current. In that case, I'm dealing with direct current, and I'm defining here the potentials, 110 volts. MC, MB is 200 volts. Here we have 320, and R1 is minus 100, and here we have minus 60. So quite easy to define all this stuff. And maybe in that area, I nearly forget that one. I just want to show you here. I'm going maybe for part selection. Just want to do, just want to see those parts here. Right now I can say right now, show me the computational net. And you see, okay, how, let's say, the springs and the threads of the screws are simplified for the analysis in order to get the best results, the worst case results. Okay. Let's show all the components again, and let's finish these steps of assigning the nets. That brings me to the next step here, where I can define my analysis parameters. Here I can work, let's say, by hand. I'm selecting maybe a source. This should be MA, and maybe between the net MA and R1, I want to bring in or key in manually the distances I have to fulfill. So it's maybe 10.5 from creepage, 6.4 from clearance, and the groove width is 1.5 millimeters. When I compute right now that guy, then it's not sure that I'm getting some paths, because if the passes between those net are longer than those distances, nothing will be shown, and therefore there is the gallop capabilities. Gallop means, okay, get at least one path. So that means, okay, if there is a pass between under 15 millimeters, it will be shown, although, let's say, there is no violation of that distances. Okay, and in the most cases, when I compute the selected source here, in the most cases I will see, let's say, the shortest pass if this pass is below 15 millimeters. So that takes maybe 5 seconds, 10 seconds. Okay, and here with those symbols I can see, okay, there is one pass. If I'm selecting that one, the passes will be shown, and when I'm activating that pass, I can see it here, not very clear. I can see it here very clear when I'm highlighting those guys. And of course, then I can spin around. I'm taking out the highlight again, and I'm bringing in, let's say, the path window. Path window, you see here it's doing a meaningful cut in that area in order to see, let's say, a clear visualization where is this path going through. The same here, pass between those two components or a net from creepage side. So that's a capability, let's say, to test, let's say, your component by hand with, let's say, some specific values. At the end of the day, you want to analyze, let's say, the whole components with these safety rules, and therefore there is a very efficient capabilities to work with some standard tables. The standard tables can be created here on the tools. You can load tables, you can create new tables, and under the hood there is just, let's say, a stupid Excel file, and in this Excel files all these values here will be stored. Here I'm taking out my gallop information, and I really want to work with these standard tables. I'm going to apply this standard table, sorry. Okay, and now I see when I'm clicking here on the components, depending on the voltage differences, the clearance path lengths and the creepage path lengths will be evaluated. Here we have maximum value, that means meet that value maximum with the worst insulator quality. This length has to be fulfilled. If there is, let's say, the paths are long and good insulator quality, this path can be shorter later on. Okay, here all that information will be stored in that environment. Here we can say, okay, we don't want to have, let's say, a hard border or a hard distance. We want to bring in some additional tolerance. We are talking about major and minor distances, and we can bring in, let's say, an additional distance of 2 millimeters, or we can also bring here a distance depending on a percentage value. So I'm lengthening my distance by 10% in order to see, let's say, the passes which are very, very close to the rules here. Okay, and with that information here, I can compute now all the sources. This takes a little bit longer. I'm guessing this will take maybe 2-3 minutes in order to, let's say, analyze the whole assembly. During that time here, I'm going for an additional feature here. This additional feature is there under, when you're defining, let's say, the metadata here, we can define here some called domains. And I'm just starting this movie with the domains. We can, let's say, reduce the complexity of our components. That means we can do, let's say, a cut in our assembly. That means, okay, we're going for adding domains with the help of a box or a sphere. We are getting here some drag handles, and with the help of the drag handles we can reduce this area. We could also bring in, let's say, the other side of that area, and also, let's say, the number of the nets will be reduced, because in that area, in that volume, only 2 nets are available. So that's one capability to reduce complexity, to speed up the process. The other one is when you're defining a sphere. You can move this sphere with the shift button, and you also have, let's say, the capability to exclude here the domain. Okay, when you push that button, exclude domain, let's say that the other side of the cut will be taken for analysis. And of course, here in that case, we have right now more nets inside. This capability of domains can also be used if you have one net here, let's say, over that one. This is one net. With the cut here, you can, let's say, split that net, and then you're able to measure, let's say, the distances here inside the net. Some customers are also using those domains to fulfill or to test the same assembly with different safety regulation from different countries. So let's go back here for the calculation. It's still on the way. Oh, good luck for me. It's right now, it's finished here, and I can see this was no movie, so we really waited 3 minutes here, and now we can see all, let's say, the creepage passes. And here with the symbols in that area, we can clearly see, are there any violation? Is there a minor violation with that symbol, or is there a major violation with the red symbol? And are there any, let's say, any maybe combinations where there is no violation, the green symbol? So now I'm going for result investigations, and I may be selecting here the combination between MA and or MB as a source, and what should I take? Let's take here maybe potential 1, and I can see here the paths. And you see, okay, here I still have my path window inside to show the behavior here. I can also filter those components in order to reduce, let's say, the passes. I can show here all the passes. Okay, without a pass window, then here all the passes will be shown. And maybe that guy here, where is it? Let's bring in the path again. This guy here, we see, okay, there is somewhere, there is also some shortcuts inside. Okay, here we can nicely see a shortcut. That means, okay, the path will be shortened by taking the screw here as a shortcut. And here I have, let's say, capabilities to, let's say, add some comments. I can say here, okay, interesting. Okay, and I can mark them, maybe set a tag. So, okay, I don't know what to do with that path here. Or maybe here I can set a tag and say, okay, this is quite close, maybe to my regulation here, and I can bring in a comment where I say, okay, might be okay. Okay, this, let's say, post-processing is taking quite a while, but here you also have, let's say, capabilities to save the camera position. That means I save this specific position, and this position will be also shown later on in the documentation I'm doing. Okay, here quite a lot of capabilities for post-processing. Here I have also capabilities to export my passes as a step file. So I'm saving that maybe as a step file live, AAA. Okay, and this step file can be imported later on in my CAD environment to see also the passes in the CAD system. Okay, here also capabilities to save these sessions in order to use it in a free viewer. So I'm saving that also to AAA. Okay, and maybe also for other people which are taking part at this simulation process. That brings me to the last point. I want to create right now a documentation. So I'm going here for my documentation capabilities, and down here in that area I'm able to influence my layout, to save the layout, to load it, and so on. And now I'd like to, let's say, change the layout a little bit. I'm loading an image for the company I'm working for. Let's take this Skia logo. I'm bringing in here the company name. Okay. Oh, it doesn't matter. I'm loading an image from the assembly I'm going to, or I analyzed. Okay, let's do that a little bit bigger, this picture. And then I just can say I want to create this documentation. Let's say create the documentation. In that case, I'm creating a PDF. Okay, let's take here also this AAA. And now the PDF will be created. This part takes me about 60 seconds. Just imagine if you have to do the documentation by hand, it will take you hours or days. And with the help of AutoCrear, you can save a lot of time. In the meanwhile, I'm going for my free viewer. This is the AutoCrear viewer. And here I can, let's say, load the session I saved right now before. It must be in my environment here. Oops, documentation seems to come to an end. Let's go here for data. Oh, okay, on the data, on the word connector, there should be ACS. So Now my component will be loaded. I cannot do any, let's say, additional analysis or change the metadata, nets or what else, but I can view here my results. And okay, when I'm viewing here the results, I can see, let's say, the passes, I can highlight them, I can do all that things to view the passes. So with that viewer, everybody who is interested in the analysis process can take part with that free viewer. In the meanwhile, let's say the documentation is done, the PDF is created, and you see here, okay, the logo, I brought in the strange name, and here is today's date. And here we can see, okay, violations are found. And let's say in that environment here, I can go for my electrical nets, or I can see here on the assemblies which parts are in that assembly. I can see the electrical nets. Is it potential? What is the potential? What is the name? Is it ground? What's the name of that net? I can see the analysis parameters I was taking for that analysis, and I can see, okay, the documentation for each violations. And I'm going for searching some items. I'm going for my username, Gia USC. I can see, okay, the user Gia USC commented some paths, and here we can see, okay, the comments, and if I'm going further here, next pass, also let's say the specific here, this one, the specific view will be saved. So you get full documentation of your analysis of the creepage and clearance passes in 90 seconds. And in the future, as I told you, will also get Word documentation. So that brings me, let's say, to the, or nearly to the end of my presentation. I told you you can bring in the step files back to your CAD system. Right now I have Creo Parametric on the screens. In Creo Parametric here we see, let's say, the direct gateway. Direct gateway can be done here by telling, okay, if comparative tracking index is already defined, it should be also brought to AutoCrear. We can transfer some additional parameters and so on, and then we can open that one in AutoCrear. And the passes here, they can also be brought into your CAD systems. And you see also these passes, and you can use here, let's say, these curves in order to get some, let's say, special features out of them in order to have a better visualization of the violation path. Great, let's go back here to my presentations. I think it's very clear that there are many benefits of these solutions. You can save quite a lot of time. You can fulfill, let's say, the safety regulations for this creepage and clearance analysis early in a design process. You can make sure that all the electrical components have a certain quality. And I think in the end that means you can save quite a lot of time, especially when I'm thinking about the documentation. That brings me to the end of the webinar. Question and answer sessions. I'm going here for my, let's say, question panel. And if you have any questions, please write it down into the question panel. And if you have later on any questions, feel free to contact us. Here we have the email addresses from Daniel Losley and from my person. I'd like to check the question panel again. So far there are no questions. So checking the time, yes, we have about 55 minutes right now in the webinar. So as I said before, the documentations, the PDF will be sent out to you on Monday. Also the download link or the YouTube link for the recording will be sent out to you. I hope this webinar was interesting for you, and feel free if you have any question to contact us. It was a pleasure to have you in that webinar, and I'd like to thank you. See you soon in one of our next webinar. Bye-bye.